All right, welcome to the class. This is Educational Research and Statistics class, and the course is one of the very important courses you need to take before and pass before being given a professional diploma in education certificate. And also, this also is a prerequisite for you to also write a TLCN examination and be certified as a professional teacher. It's a very important course, and the course is in two sections. We have the educational research part of it, and we also have the statistics part of it. What is the course outline? The course outline, the course of the lecture, will be looking at what? In the course of our learning experience, we'll be looking at the concepts and typologies of educational research. We're looking at planning the research, data collection techniques, report writing. Thereafter, we proceed to the background to statistics, organization of data, graphic representation of data, measure of what? Central tendency, a measure of dispersion, and lastly, we look at correlation. That's it. And what's the general course objective? Of course, the course here is intended to expose students to the rudiments of educational research and to prepare them for carrying out an empirical study in the field of education. So it is expected that at the end of this course, you should be able to know the rudiments of educational research. And again, the learning, of course, during this in a school setting, you should be able to understand or apply educational research, empirical method of research in identifying problem and finding solution to problem that you might encounter as a teacher. Then, more importantly, the knowledge gained in the course will be used by students in the following semester, which is the second semester, all right, to carry out a study and submit a research report in the coming semester. So what we're saying here is that the knowledge you gain here will always have an immediate effect. It is a prerequisite to the course whereby you afterwards identify an educational problem and use empirical method in trying to find solution to it within the 3 to 4 months, whereby you have to submit, also how to narrate or document your experience as you find solution to the problem. All right, that of course, these are two main objectives this course is meant to achieve. All right, so this part of this lecture will start with the statistics part of it, and in the statistics part of it, all right, these are the outlines which was earlier read, and the part of it containing what the statistics part of it is what has been highlighted here, which will talk about the definition and types of statistics, all right, and the likes. So we take them in turns. And the first part of it, we want to look at the concept which we mean by what? By statistics. Why study statistics? Why study statistics? Yeah, before we look at the definition of statistics, of course, the whole idea is about data. Of course, we believe that data is everywhere, and the collection of data are relevant to the problem being studied, and it's commonly the most difficult, expensive, and time-consuming part of the entire research. So for anybody, even for humans, data is important. We need the data. We need the data to take informed decision. And for you to take a decision, of course, you must be aware of what is going on. And such information will ease taking a very good decision. So statistics are used to make many decisions that affect our lives. No matter your career, you will make professional decisions that involve data. Understanding statistics method will help you make this decision effectively. So if you're aiming at making an effective decision, then there must be a possibility of data gathering. When you gather such data, how do you make meaning of the data? And from the data you haven't made meaning, how do you take informed and effective decision? Right. Moving forward, then what is statistics? It is the science of collection, organizing, presenting, analyzing, and interpreting data to assist in making more effective decision. So statistics is the science of collecting, organizing, analyzing, and interpreting data in order to make decision. The bottom line here is the decision we intend making. And if we intend making a decision, then we are saying that what? We must have the knowledge of how to collect, organize, analyze, and interpret such data. Similarly in statistics, or similarly in research, educational research, it is believed that any decision that is meant to be taken, we must be able to gather data, all right, organize the data, all right, analyze the data, and interpret the data before we take an informed decision. Then the central of what we're saying all the while has been data, data, data. Data, of course, is an information which can come in several forms. Can come in several forms. So statistical data are usually obtained by counting or measuring items. Most data can be put in the following categories. It can either be quantitative or qualitative. When is it qualitative? It's qualitative when it is a non-numeric data that are observed, described, and subjective. It is collected through observation, interview, conducting focus group discussion, etc. Of course, when a data is collected, it's collected in forms of what? In form of text, words. Example of such could be what? Okay, you could approach a person and tell them, what do you think about research class? Oh, when the person afterwards, when the respondents or the person you're asking the question have to come with what? Expressing their understanding about what statistics class is about. All right, definitely it's going to do such in what? In words. Then that's a form of interview. Or you try to sit back and observe their reaction during the class. Such reaction you're observing there, all right, we have to put it into words. Oh, students were elated, or students were frowning, or they were this. This will come in form of words. Then it is not what? It is non-numeric. It is coming in words. Then it is a qualitative data. Such will be read, and when it is read, one can make decision either the statistics class, research class is good, or statistics class is interesting to the learners or not interesting to the learners. Also, we also have another type of what? Of course, in another category of data, it can come in another category called quantitative data. These are observations that are measured on a what? A numerical scale. So it involves what? It involves numbers. For instance, you have to gather data about what? About distance traveled to college, or number of children in the family, the weight, or the achievement in a test. These are things you have to work that is measured in numbers. Of course, if you have been given a test, when it is marked, the score there will be what? In numbers. If I'm to gather the distance traveled by all learners to the school, the data I'm going to gather there will be in what? In words. And also the number of children in a family to be counted, that will come in words. The weight of everybody in a class will also be gathered in what? In numbers rather. It will be gathered in numbers. All right. These are the this form of data is what we call quantitative data. It's quantitative because it's coming in what? In numbers, which significantly differ from what? Which significantly differ from when it is coming in what? In words. So having looked at qualitative data, which is presented in what? In words, and also quantitative data, which is presented in numbers. All right. Data. Another term we also want to look at is a sample. Right, sample. What do we mean by sample? It's a term we will still have to use repeatedly in the course of the class. The number of these terms we're talking about will still be used countless times, almost countless times in the course of the lecture. A sample is, before a sample, of course, there is what we define as what? Population in statistics. I want to hold on to start with population. All right, population here, which differs significantly to the way it is being defined in the field of geography or economics. All right, here we are talking about what? Every element that shares similar characteristics that is of interest to the researcher. For instance, for example, if I am a researcher, I intend studying about learners, secondary school students' performance in mathematics, or secondary school students' performance in secondary school, okay, senior secondary school student performance in physics. My population of the study there will be what? All students that study physics in secondary schools. And if I'm limiting it to an environment, if I say, for instance, it is in Mushin, then I'm talking about all physics students in Mushin local government area. If I go to a school in Mushin and I meet a commercial student or a student that is not offering physics, that particular student will not be part of my population. It will rather be what? It is not part of the concern to me as a researcher. So it will not be considered, or data will not be collected from such what? From such learner. Similarly, if I see a teacher there, I'm not bothered about teacher. It is not of my interest as a researcher. If I see junior secondary school students, that is not of my interest. So my interest is what? Secondary school students that offer physics and are in senior classes. All right. So again, population refers to what? All elements or subjects that share similar characteristics that is of interest to the researcher. The similar characteristics there refers to what? Refers to all students that is offering physics. All right. And the interest there is the physics students that I'm after. All right. Having said that, more often than not, it could be what? It could be difficult at times talking to all students due to certain limitations in Mushin local government. If I'm to do a study and I'm to do a study on what? On all students that is offering physics. Well, due to time and resources, it may be difficult reaching out to all the students. Then there might be need for me to select some parts of the students. All right, study them. That part I'm selecting is what I mean, what we refer to as what? As a sample. So a sample is selected to represent the population in a research. So a sample is a subset, which is a part of a population. And the goal is to use the result obtained from the sample to help answer questions about a population. Also, such sample, when it is being studied, can also be used to generalize to the entire population. So data, then the next term we want to define is data. Data consists of information coming from observation, counts, measurement, or responses. In a layman parlance, we refer to it as information. It could come in what? It could come in a number form. It could come in an alphabetic form. It could come in an alphanumeric form too. It is in numeric form when it is what? When it is in quantitative data. Of course, it's coming in numbers. Also, example of numbers are what? Scores of students in the test, the matriculation number of students, etc. Also, it will come in form of what? In form of alphabets. It could be in form of alphabets in terms of names of students in a class, in form of alphabet in terms of what? The expression of student during interview. Again, it will also be alphanumeric too. This is alphanumeric when it has a feature of both numeric and alphabets. For example, all right, the JAM registration number of students, the house address comes with what? Both alphabet and numbers. JAM registration also comes with alphabets and numbers, and the list is countless. All right. Moving ahead, we also want to look at what? Statistical data. These are data that are usually obtained by counting or measuring items. All right. And under that statistical data, it is of two types we're going to look at. We have what we call a primary data, and we also have what we call a secondary data. All right. What are primary data? As a researcher, when you are trying to gather data in the field of research and statistics, right, there are means by which we collect data. There might be need for you as a researcher to gather your data because you have to take decisions based on the data you are gathering, which we defined as statistics earlier. So primary data are collected specifically for analysis desired. They are collected directly by the researcher. When such is collected, they are collected by people that are more concerned I'll give an instance. If I'm to conduct a study about learners' perception about research class, and I want to gather that data, I went to students in the class to collect the data from them. Oh, these are people that are concerned. They are the learners. Then the data I'm collecting is directly from the learners. Then that's what we refer to as what? As a primary data. Another example that can also be given here is that I am to conduct a study from students, from learners, about their perception or their understanding of what was taught in class in mathematics. So I went to schools and I met with the student concerned and I started collecting data from them, either primary or either qualitative or quantitative data. Irrespective of that, that data I'm collecting there is directly from the student that are concerned. Then that's a primary data. However, for secondary data, these are data that have already been compiled by someone else. So as a researcher, you have to extract information from those documentations, which will come in terms of journal, bulletin, and books. You have to scavenge those information to the extent to which that will suit what you want to study. Then use such information. Then at that point, it's a secondary data. So another example of a secondary data, for instance, is that when you have to use a secondary data is in a situation whereby you are making a study and maybe it could be very difficult for you to reach the people concerned that can give you the first-hand experience of what's happened at that particular moment. Then there will be need for you to use a secondary data. A clear example, for instance, is that you want to see, maybe you're conducting a study. There is a type of study we'll still look at in the course of the class called historical research. And you want to study about Nigerian educational trajectory before maybe before the Civil War and after the Civil War. So for you to gather data about the Civil War or before, during, and after the Civil War, there is need for you to actually come with contact with people that actually were in existence in what? Before Civil War, during Civil War, and after Civil War. So that shows that what you have to do, it may be a bit difficult for you to gather people that actually experienced those three stages of Nigerian educational adventure during those three phases. So what you might have to resort to is resort to literatures that was written before, during, and after the Civil War. So when you read several books, journals, bulletins that was done then you have to scavenge information that suits your own study. Well, of course, those particular documentations were made not purposely because of what you intend studying now, but it was made with the bias of what they saw around then, which does not exactly tally with your own experience. Then there will be need for you to read through them and bring out information that relates to your own study. And what relates to your own study, at that point, you are gathering that data not primarily from the people directly, but from another source that has been documented. That's a clear example of what we mean by secondary data. So from here, we should be able to also differentiate between what we mean by primary data and secondary data. It is primary data when you are coming in contact with the people that you are collecting data directly from the subjects, people concerned. However, when you have to go to documentation before you gather such data, all right, that has been done by maybe earlier researchers, all right, then you're doing what we call a secondary data. All right, the next one we're going to look at is what we call a constant. A constant. What is a constant? Anything that is fixed in numerical values refers to as what? As a constant. Anything that is fixed in numerical values refers to as a constant. All right, before we move on. All right, then we would have also looked at variable, but in the course of the class, we would definitely look at that. All right, the opposite of constant is variable, but we'll look at that in the course of the class. Other terms that we still need to look at again is a parameter. A parameter is a numerical description of a population characteristic. So if you have any description, having defined what population is and what sample is, if you have any description of what talks about a population, then we call it a parameter. However, if you have selected a part of a population, all right, now you have a what? You now have a sample, all right? That particular, if you have any what numerical description of that particular sample, then we call it what? Statistics. All right. Knowledge check, or to also drive home the explanation on the parameter and statistics, we have to look at this. Yes, decide whether this numerical value describes a population parameter or a sample statistic. All right, the first one is a recent survey of a sample of 450 college students reported that the average weekly income of students is 6,525, while the other one says the average weekly income of all students is 7,505. All right, the first one, of course, is talking about a sample of 450 college students. So that value here, the average income of 6,525 here, is talking about what? It's talking about a feature of a sample. So that tells us that the first instance is a what? Is a statistic. Is a statistic. The second one is an average income of all students, which is the population of all the students. Of course, that's a population. And the population, because it's defining the what, is describing the future of a population, then it is what? It is what we call what? A parameter. It is a parameter. Moving ahead, what are the types of what? Types of variable. Of course, the variable again, as we said, is what? Is anything that varies, that can change. It's still a time we're still going to say about countless time before the end of the class. All right, a variable is anything that can change. Its opposite of a variable is referred to as what? As a constant. The opposite of a variable is referred to as a constant. So variable can also be what? Can be classified as discrete, and also it could also be continuous. When is a variable discrete and when is a variable continuous? A discrete variable is expressed only in countable numbers. Okay, it is what? It is countable in a finite amount of time, e.g. integers. So if you have to do any counts such that it's only the figures, the whole numbers you have to use, the 1, the 2, the 3, the 4, then you're doing what we call what? We are doing, that's a discrete variable. However, as opposed to continuous, a continuous can take what? On infinite numbers of values. It can take the form of, it takes forever to count. For instance, time. If you ask for somebody's time, somebody's age, even when you are measuring the time and the age, it's also difficult. You can also what? It's also difficult for you to say that this is the exact time. If I'm telling you the time, now if you ask me what the time is, if I tell you the time is 7:05, definitely there will be seconds counting already. So in between that particular integer, in between that 7 and 8 o'clock, there are all other counts there. Even if I tell you 7:10, before 7:10 and 7:11, there are other counts in between them that are what? That are infinite. Similarly, the age. If I ask of anybody, how old are you? If you say it's 20 years of age, then of course you should also be expecting to hear the number of months. After the number of months, how many weeks? After the weeks, maybe possibly if you're talking about what? Hours, maybe time. Of course, there are infinite numbers in between those integers. That makes it what? That makes it continuous. So measuring a variable. To establish relationship between variables, researcher must observe the variables and record the observation. This requires that the variables be measured. So in the field of statistics and measurement, the process of measuring a variable requires a set of categories called scales or levels of measurement, and is a process that clarifies each individuals into one category. So when measuring what? In measuring variables, which says anything that can change or varies, all right, there are scales or levels by which we measure. So the scales and the levels by which we measure is what we will then go through. All right, what are those levels? The levels of measurement determine the statistical calculation and meaning the level of measurement determines which statistical calculations are meaningful. So basically, we will have 4 levels of measurements. We'll start from, and they are in hierarchy, from the lowest to the highest. The first one is what is the nominal level of measurements, the ordinal level of measurements, the interval level of measurements, and the highest of it all is what is the ratio level of measurements. So we start with the first one, which is what the nominal level of measurement. In the nominal level of measurements, all right, it is an unordered step of categories identified by name. Nominal measurement only permits you to determine whether 2 variables are of the same or different. Basically, what we use here is what? We use it for identification. Nominal level of measurement is basically used for identification. So for identifying, we just have to what? Nominally give a name to a particular category to identify them. So it could be what? It could be name. It could be what? It could be, for instance, I'll give an instance of a what? If you are to what? If you are in a football team, of course, they identify by their numbers. And the numbers by which they are identified by, from 1, in a football team, of course, there are maybe 22 of them or 23 of them. And on a football pitch, we expect only 11 from each side. So in a team that is meant to represent, while the rest of them are meant to be what? On the bench, out of a team. So in Nigeria, for instance, is to pay a particular team, they are going with a team of what? Maybe 23 or 22. In that team, 11 can only represent them at a time. So in that particular team too, that 1 to 22 are given the jersey number. The number labeled on their jersey is strictly labeled on their jersey is strictly for identification. So number 1, number 2, number 3, up to the 22nd or 23rd person in that particular team. So when such number is given, that number 1 does not mean you are the first or better than any other person in the team. And you being number 22 does not mean you are the last in the team. But what we use it there for is just basically to identify the person. So of course, number 9 doesn't mean what you are, or number 1 and number 22 doesn't mean being the best person in the team, and number 2 doesn't mean you are the worst person in the team. Basically, what we use them for is for identification. Similarly, in the streets, you will see several houses. In a street, if you enter a street, when you say the first house is labeled number 1, the second house is number 2, up to the last number in the street. So the first house doesn't mean it's the best house, while the last house doesn't mean it's the worst house. Basically, what that is done there is strictly for what? Strictly for identification. So aside the nominal level, which is basically used for what? For identification. All right, the next level we'll look at is the ordinal level. In the ordinal level of measurement or scale of measurement, right, we use it for identification. In addition to identification, which is a basic feature of the nominal level, it also looks at what? It also rates or rank. It also has a unique feature of ranking. So it's an ordered step of category. Ordinal measurement tells you the direction of differences between 2 groups or individuals. The value in one category is larger or smaller than value in the other category. E.g., for example, a clear example is what? When you have an athletic race, in a 100 meters race, the first person that gets to that particular finish line is the first. The second person is what? Is the next second, while the next person will be the third, the fourth, meaning that the first person who gets there, all right, is ranked number 1, number 2, number 3. So apart from putting that ranking there as number 1, shows that that person finished the race first. So apart from, so there is not just only that number 1, we have also ranked it as what's being the best in that particular race, follow by subsequent numbers that follows. Also in a class setting, so we have what? We have the first person, the report card that is being done at primary school level, which is done with percentage. comes with first, second, third, fourth. So those ratings there has been put in consideration that what the person who has the highest percentage there comes first. The next person who has the highest percentage comes second, followed by third, fourth, to the last person in class. So similarly, the rating scale written here are excellent, good, fair, and poor. This is also in what? In a scale, in an ordinal scale of measurements. Next to that, we have the interval scale. The interval scale has the feature of the ordinal scale of the nominal scale of measurement, ordinal scale of measurement. In addition to that, it has what? Equal size category. Equal size category. So in an interval scale of measurement, identify direction and the magnitude of difference. All right, the direction and magnitude of difference is that what there is an equal sized category, meaning from the first and the second person, between the first and the second person, and the second and the third person, the category or the size between them is the same, meaning from first to second, second to third, third to fourth. All right, there is equal size difference in between them. So in addition to the base features of identification and ranking being possessed by the earlier two, so he also has the unique feature of what? Of equal size category. In addition to that, the 0 point is located arbitrarily on the scale. So if you say there is a 0 point on an interval scale, it is just arbitrarily assumed. It is a set of numerical measurements in which the distance between the numbers is of a known constant size. So that's what we mean by what? The equal size category. While the last scale of measurement, which is the highest, all right, is the ratio scale of measurement. The ratio scale of measurement here, it is an interval scale where value of 0 indicate none of the variables, meaning that if you measure anything at this particular scale and you get 0, it shows that that particular feature does not exist in that particular event being measured. All right. The ratio scale identifies the direction and magnitude of differences and allow ratio comparison of measurements. So, of course, manipulations such as addition, subtraction, division, and addition, subtraction, multiplication, and division all can be done at this particular category. It is the highest It is the highest scale of measurements. Well, a brief summary of what has also been described here is that under nominal is basically for categorization. The first, just for identification. That's what is being done under nominal. But for ordinal, it does categorization as well as ranking of the variables. While in interval, it does It does the categorization, ranking, as well as equal spacing. Again, in the ratio, which is the highest rating level of measurement, we have categorization, ranking, equal spacing, as well as through zero value. All right, this summarizes the 4 levels of measurement. All right, the last part of this particular session will be the types of statistics. The types of statistics, basically, we look at the basic 2 types of statistics that we have, which is the descriptive and the inferential statistics. In the descriptive statistics, we are talking about method of having given a data. How do we organize data, summarize data, and present data in an informative manner, right? So if you are given a set of data, how do you make meaning, organize such data, summarize the data, and present the data in an informative manner? Because if you are given the data the way they are, we call it a raw data. When it's a raw data is not easy to make meaning of. So if you describe that particular data, making meaning of an already existing data, then you are doing what we call a descriptive data. Under this, right, which is basically what we'll also start with in our subsequent classes, we'll be looking at drawing a frequency distribution. After frequency distribution, we'll also be looking at how to do visual descriptors, and after visual descriptor, the mean, median, and the mode, which is the measure of central tendency, measure of dispersion, will also be we'll look at. Also, in inferential statistics, which is the other type of statistics, is a method used to determine something about a population on the basis of a sample. So we said population again is the entire set of individual objects of interest or the measurement obtained from all individual or object of interest, which is to the researcher. So if there's anything that interests you that you are collecting data about, then you're doing what? That's a population. But when you now decide to select part of a population, all right, to study, all right, that particular part to study is what is called sample. There are instances whereby that particular sample, when we study it, whatever we find out of that sample, we infer to the entire population. Then that we're talking about what? We're talking about inferential statistics. So we study a part, from whatever we observe from that part, we infer to that. For instance, a clear example is that, which I do take as example, is that for anybody who has never been to the Southwest before, all right, and has never had much contact with Yorubas, and he came to Southwest, maybe he's a northerner or easterner that comes to the south to Lagos for the first time and started having Yoruba friends. And for every weekend, for he has stayed maybe like 5 years in Lagos, for every weekend, all the Yoruba friends he or she has, they always have an Owambe party in the weekend. Of course, that person can sit back and say, Yoruba people, they like Owambe. The conclusion made there is not to say that he met with all the Yorubas in Southwest. He only met with what? He only met with some of them. The some he has been able to meet with is a clear example of what we call sample. And the observation he made from that sample, he now inferred it to the entire population to say that all Yorubas, they like Owambe. So that's a clear, a miniature example of what we mean by inferential statistics. All right, I thank you for this session. All right, the next section will continue from descriptive statistics. Thank you.